We have discussed this point a few times by now, but let me repeat it again. Look at the asymmetry among the interpretations of the fractions. When we were comparing the risk differences, which is for example, the the risk of developing chronic heart disease among high cholesterol individuals compared to those with normal cholesterol, we see that those with high cholesterol have 13.86% higher probability of developing chronic heart disease compared to normal. And the inverse was exact opposite with only just a negative sign. That is, the normal cholesterol individuals have 13.8% chance of developing chronic heart disease, lower than those with high cholesterol. But when we take the relative risk, these two values, although mathematically equal, but in the interpretations they are quite different. For example, here we see that individuals with high cholesterol have 60% higher risk of developing chronic heart disease compared to normal, and the opposite is like the probability of developing chronic heart disease among normal cholesterol individuals is 38% lower than that of high cholesterol. Not exactly opposite of that, at least mathematically speaking, right? So let's see what is going on. Suppose the relative risk of developing chronic heart disease among group A was 2, and among group B it was 1. So when we take the ratio of these two values, group A to B, then the values would be 2 divided by 1, which becomes 2 obviously. But when we compare B to A, it will be 1 divided by 2, which is 0.5. So it is not minus 2, but in fact it is 0.5. Although if you think deeper, they mean the same thing, but at least in the first glance they appear very asymmetrical. So let's see what is going on in here. This is due to the inherent nature of the fractions. One of the ways it is going to reach infinity, and in the other opposite direction it is going to stay between 0 and 1. For example, say the odds of developing an event among group A, instead of 2 it was say 10. So now we see that A to B becomes 10, but B to A still remains between 0 to 1, right? So the odds for A to B has increased substantially, but B to A remains 0 to 1. What if we increase it to 100? So now we see that A to B has increased substantially, but B to A still remains between 0 to 1. So one will just keep on increasing, the other will stay between two limited numbers, 0 to 1. Please do remember that when it comes to fractions, the neutral value is 1, in contrast to the subtractions where the neutral value is 0, which means that there's no difference. But when it comes to fractions, 1 is the neutral value, because that means that there is no difference in the ratios. For example, if it is group A, the odds is 1, group B, the odds is 1. So 1 over 1 is 1. So the neutral value 1 indicates that there is no difference between group A and group B. This is in contrast to what we studied during the means or continuous variables, where 0 was the neutral value. Anyways, so moving on, if say group A had the odds of say 1000, now we see that the comparison of A to B is still increasing. B to A has decreased, but it is still between 0 to 1. And if we increase it to say 10,000, still we see that A to B is still increasing, but B to A remains between 0 to 1. So what I'm trying to explain is that there is an asymmetry in the interpretation, although they are mathematically equal, but in the interpretations, it becomes slightly become more complicated, and you have to understand why these two values are not uh, exactly inverse of each other, right? So this is because how the fractions work. One of them will keep on rising, reaching theoretically infinite, but the opposite will stay between 0 and 1, no matter how much was the difference. One way of handling that complication or that asymmetry is to use the logarithmic transformation of those numbers. In that, what we do is we convert the baseline, that is 1, that is the neutral value in case of fractions, we convert it into 0 arithmetically or logarithmically. And then we also convert 0 into negative infinity, and we convert positive infinity to positive infinity. Let me explain it to the example on which we were working, and then it will be clearer. So again, visually, if you see here, the neutral value of 1 in the fraction will now be converted into 0 in logarithmic transformation, and the fraction 0 will be converted into negative infinity, and the positive infinity will remain positive infinite. Okay, so for example, in here, if we take the equals log natural of this value, 1.6, it becomes 0.47. And if we take the log natural of 0.6, it is in fact the arithmetic opposite of the top value. Similarly, if we take the log natural of odds ratio of high cholesterol individuals developing chronic heart disease, log natural of 1.95, and it becomes 0.67 and the opposite of that log natural, the odds of developing chronic heart disease among normal weight individuals, it should be again exact arithmetic opposite of that, which is minus 0.67. So that's one way of handling that complication, which is used in specifically in the logistic regression that we will learn in the next section.